A statistician can have his head in an oven and his feet in ice, and he will say that on the average, he feels fine. Oh, that's a mean joke. Get it? Average, mean. Anyways, we will be calculating now z-scores and x values from probabilities. And to see why we might want to be able to do that. Well, sometimes we were talking about, the top something percent. And you want to know, oh, what do you need to be in that top something percent or in the bottom something percent or the middle something percent? And today's lesson is about helping you figure out how to find the values that correspond to different percentiles. All right, we have adult male heights are on average 70 inches with a standard deviation of 4 inches. So we've seen this data before. How tall must an adult male be to be in the top 2.5% of heights? And what does the top 2.5% really mean on our curve? Well, basically it means that 97.5% of the heights are lower and 2.5% are higher. Now, in this case, the example I gave you, we can actually figure out pretty easily using this from my prior notes. And you see here's the top 0.15%. And if I add in this piece, that gives me the top 2.5%. So that's 2 standard deviations above the mean. So the z-score, which corresponds to this area, would be 2. And then I can actually use the formula that we saw in our prior set of notes, G2, is that z times the standard deviation. So I can get x if I multiply the z-score for x times the standard deviation and add it to the mean. In this case, the top 2.5% of heights would be 2 times 4, which is 8, plus 70, which is 78. Now, most times we're not going to have nice, easy numbers that we can use the empirical rule for. Actually, let me go to the previous. Where are we? Previous. If I was to ask you, well, and I'll get to it. If I was to ask you between, top 3%, I don't have the z-score for that. So how do we find z-scores for z-scores for percentages that we're not familiar with? Well, we're going to press second distribution like we did before, and we're going to scroll here to inverse norm and press enter. Then if you have a newer calculator, which most of you should, you see this little screen here, which prompts you for area, mu, sigma, and then gives you the chance to paste it. So the area, you're going to use the area to the left of the z-score, to the left, to the left, to the left. Let me say that many times, of z. And this should always be a number less than 1. Mu, make this sure this is 0 since we're doing z-scores. And sigma should be 1. We're going to go ahead and scroll then down to paste and press enter, and it will give you the value for the z-score. Older calculators will only show this inverse norm part. And so you can just put in the area to the left of z and press enter, and it'll give you the z-score as well. So it's actually pretty easy on the older calculators too. Here's a big tip. It really helps to draw a quick normal distribution curve and shade in the area to the left of z, or at least definitely mark it out. So let's say we wanted to know how tall must an adult male be to be in the top 5% of male heights. And we don't really have that on our empirical rule, so we'll have to go find the z-score. Where's the top 5% of heights? Well, ask yourself, is it in the lower end of the graph or the higher end? You should say it's in the higher end, and it's 5%. So how much is before that? 95%. So when we do inverse norm, we're not going to put in 0.05. We're going to put in 0.95 because that's the area to the left. Then we can go ahead and calculate the x-score by, well, first of all, let me get my z-score, which is 1.645. Once I know that, and since I already know the standard deviation for male heights and the mean, I can put it all together and get a height of 76.58 inches. Now let's look at another example. Tomato box fillers are designed to get an average fill of 80 ounces, which is 5 pounds, with a standard deviation of 4 ounces. Apparently I'm very attached to 4 as standard deviation. The first question is asking, the lightest 5% of boxes will weigh no more than blank ounces. Well, where are the lightest boxes? Are they up here on this end of the curve or on the bottom end of the curve? They should be on the lowest weights, so down here on the left side of the curve. We want 5% there, so this is actually pretty easy. The z-score right here that marks the boundary has 5% of the weights to the left, so I just do inverse norm of 0.05. And I get negative 1.645, which kind of makes sense because before when I had the top 5%, I got positive 1.645. All right, so we can go ahead and use this formula again to find our x value, which would be negative 1.645 times 4 plus 80, or 73.42 ounces. So we can say that the lightest 5% of boxes will weigh no more than 73.42 ounces. Now here's an interesting question. 95% of the boxes will weigh at least blank ounces. Well, if we're talking about, are we talking about 95% over here or the top 95%? Well, at least means more than, so that must be the top right. And that's the area we're talking about, the 95%. And the boundary is right here. So how much area is to the left of that boundary? It's 5%. So believe it or not, this question has the same z-score. It's kind of asking the same thing as the first question. So since I had the same z-score, I know I'm going to get the same x value, 73.42 ounces. So that can be a little bit mind-blowing that both of these are kind of asking for the same weight. Now, let's say we wanted to get an average fill of the heaviest 10% of boxes. Where would the heaviest be? Well, it's not on the lower end, it's on the higher end of weights. So I'm going to go ahead and shade in the top 10% over here. And we need to find the z-score, and that's the area to the left. If I put in inverse norm of 0.10, I'm going to get the wrong answer. I need to do inverse norm of 0.90, and that gives me 1.28. Go ahead and use that formula again to find our x values. 1.28 times 4 plus 80 is 85.12 ounces. So the heaviest 10% of boxes will weigh at least 85.12 ounces. So the other thing that we can do is we can determine the middle range. So like the middle 90% of boxes. So what we do is we kind of slice the graph in 3 sections. I'm going to have the middle 90%, and then I'm going to have a piece on the left and a piece on the right. To do that, to figure out the piece on the left and the piece on the right, I'm going to subtract 90% from 100%. But since what's left over goes on both ends, you need to add this in, you need to divide that number by 2. So you can think, oh, 90%, there's 10% left, so 5% goes over here. All right. You're going to use your answer in number 2 to look up the z-scores corresponding to the left section. You're also going to have a z-score for the right section, and it should just be the positive version of the negative z. Convert both z-scores to x values, and you're done. So let's do this middle 90% again. That's the middle 90, and remember, left area is 100% minus the middle, and then divide by 2. So that would be 100 minus 90% divided by 2. That's 10% divided by 2, or 5%. So that's 5%. So this boundary is at the inverse norm of 0.05, which is negative 1.645. And I can find the x value, negative 1.645 times 4 plus 80. And I get that 73.42 ounces. On the top end, the z-score is pretty much, it's no farther away from the mean than this one, so it's positive 1.645 times 4 plus 80. And I get 86.58 ounces. So the middle 90% of boxes will weigh between 73.42 and 86.58 ounces. So one more to practice. What range of weights will be in the middle 80% of boxes? Same thing, go ahead and mark the middle 80%. And we're going to basically take the leftover area, which is 100% minus 80% divided by 2. That's 20% divided by 2, or 10%. So this area, the purple, is 10%. There we go. And then I can do inverse norm of that left area, which is going to give me negative 1.28. Then I will go ahead and substitute in that negative 1.28 with my standard deviation and my mean, and I get 74.88 ounces. Now, the z-score for this boundary is the same, it's just positive, so I'm going to do the same problem with a positive 1.28 times 4 plus 80, and that gives me 85.12 ounces. So the middle 80% of boxes will weigh between 74.88 ounces and 85.12 ounces.